The whole internet is buzzing about an unusual discovery on Google Maps in Antarctica. Southeast of Japan's Showa Station, someone noticed a giant door standing out in the icy landscape. Some call it Bigfoot's vacation home, or a shuttle from Star Trek. Others say it's a blown-off Boeing door that somehow ended up in the snow. Scientists have a way less exciting explanation. It looks like the so-called doorway is actually part of fast sea ice. It floats near the coast where the water is shallow and islands are scattered around. This spot could simply be an iceberg that got stuck and is slowly melting right where it is. You can see other icebergs nearby in the same area. Ice flowing around a solid underwater rock could have formed a natural pattern. The ice is pretty thin here, and because of the rocks underneath, the ice forms unique shapes. Geologists add that the mysterious find is just a rocky ridge sticking up because the ice level has dropped a bit. The top of it is the ridge, and the sides are two snow tails, long streaks of snow shaped by the wind. These snow tails show which direction the wind usually blows in this area. The previous mysterious Google Maps find in Antarctica was a pyramid that turned out to be a mountain. You can easily find it if you scroll all the way to the Ellsworth Mountains. It's the tallest mountain range in Antarctica, and it stretches for almost 250 miles. It's not the first pyramid on this continent, as explorers from the British Antarctic expedition found another unusually shaped mountain and nicknamed it the Pyramid. But this one didn't have a pyramid shape after all, so nope, there are no pyramids in Antarctica. Sorry to ruin it for you. In 2011, scientists from Chile found a strange fossil in Antarctica that looked like a squashed football. It received the nickname The Thing because it looked like something from a science fiction movie. It turned out it was a giant soft-shell egg from around 66 million years ago. It was more than 11 inches long and 7 inches wide. The only bigger egg ever found was of the extinct Madagascan elephant bird, which was 1.5 times as tall as Michael Jordan. The Antarctic egg is also special because it's the first fossil egg ever found in this part of the world. So, whoever left it there must have been huge, probably a giant sea reptile that lived long ago, like a mosasaur. This is surprising because most scientists thought these creatures didn't even lay eggs. The egg is also unique because it has a thin eggshell and no pores, which is totally different from most dinosaur eggs. Scientists did a lot of work and studied 259 types of living reptiles, like lizards and snakes, and their eggs. From this, they figured out that the creature who laid the egg was probably at least 23 feet long, not counting her tail. During the late Cretaceous period, this part of Antarctica must have served as their nursery. Paleontologists have found bones of tiny mosasaurs and plesiosaurs in the same area, as well as bones from the grown-up ones. If you've ever lost your ID and still can't find it, try looking under the Antarctic ice. Well, at least it worked for a man who was reunited with his security access card after 21 years. Rod Budd, a technician studying sea life on the Antarctic seafloor, spotted the card while he was diving at a place called Cape Evans. Rod thought it might be a credit card, so he put it in his pocket and kept working. When he took a closer look, he realized it actually belonged to someone named David McCaw. The card stayed with the research institute where Rod worked for 8 more years, until they finally managed to find David. It turned out that he had never been to Antarctica. In 2003, someone broke into his car in Wellington, New Zealand, and they tossed the contents of his briefcase into the harbor. So, the card traveled over 2,400 miles in 13 years. There aren't even ocean currents that move directly from Wellington to Cape Evans. If the card went through different ocean currents, the journey would take around 1,000 years. So maybe it got attached to something else that could float more easily, like a piece of debris or a plant that can grow on objects and make them buoyant. Or maybe the person who took David's briefcase was on a ship that went to Antarctica. Or the card somehow stuck to the bottom of a research boat that ended up there. In case you want to see probably the coolest find from Antarctica, you gotta head to the 2025 World Expo in Osaka, Japan. They'll display a meteorite the size of a rugby ball that came all the way from Mars. A Japanese research team found it in Antarctica in the year 2000. They believe a massive asteroid impact blasted the meteorite off its home planet before it traveled through space and landed on Earth. It's one of the largest Mars meteorites ever found, weighing 28 pounds. Scientists studied the gas inside the rock to confirm it's from Mars, and they also found special minerals inside that form when water is present. This means Mars likely had water a long time ago. So, studying the rock may help us learn more about whether life could have existed on a red planet. A team of sound experts found a huge underwater canyon in Antarctica, thanks to bad weather. They had to pause their work at the Casey Research Station. Instead of waiting around, they decided to use the unexpected free time to map the seafloor near Adams Glacier. And that's how they found a canyon that is almost 7,000 feet deep, almost 30,000 feet wide, and stretches over 28 miles away from the glacier. The icebreaker they were on uses a special tool called a multi-beam echo sounder. It sends out sound waves in a fan shape under the ship, then listens for the echoes to create a detailed map of the ocean floor. During the mapping, they discovered just part of the canyon before they had to return to the research station. But when bad weather returned, the ship went back and mapped even more of it. They were working among waves up to 13 feet high and winds up to 50 knots, but they still managed to get about 15 hours of data to complete their map. On their way back to Australia, they stopped one last time to fill in any missing spots on the map. This advanced mapping technology is helping scientists learn more about the history of glaciers and ocean interactions in Antarctica. A scientist was browsing through satellite images for brown trails of penguin droppings and found 4 new colonies of emperor penguins in Antarctica. This means there are now 66 breeding colonies for this vulnerable species. These new colonies likely have been around for years, though they're mostly small, with fewer than 1,000 pairs of breeding penguins each. Some of these colonies are close to other penguin areas, like the one that's not far from an old research station that never reported penguins nearby. One of the new colonies was found close to a place called the Lazarev Ice Shelf, where there used to be a larger penguin colony. They thought this colony went extinct in 2019, but it seems the penguins have just moved a bit because of changing sea ice conditions. If we add the newly found penguins to the total population of this breed, it doesn't change the picture a lot. But it can help scientists see how emperor penguins adapt to the changing conditions.
In 2011, scientists from Chile found a weird-looking fossil in Antarctica that looked like a squashed football. Almost 10 years later, the rock just sat on a shelf in Chile's National Museum of Natural History with no specific label. It went by The Thing in the museum because it looked like something from a science fiction movie. When the scientists finally got their hands on the strange fossil, it turned out it was actually a giant soft-shell egg from around 66 million years ago. This one is more than 11 inches long and 7 inches wide. A regular chicken egg is just 2.5 inches long, and an ostrich egg is almost 6 inches long for comparison. So, the Thing won the title of the biggest soft-shell egg ever found and the second largest egg of any animal we know of. The only bigger egg that was ever found was that of the extinct Madagascan elephant bird, which is also 1.5 times as tall as Michael Jordan. The bird, not the egg. The Antarctic egg is also special because it's the first fossil ever found in this part of the world. So, whoever left it there must have been one big creature, probably a giant sea turtle that lived long ago, like a mosasaur. This is surprising because most scientists thought these creatures didn't even lay eggs. So this discovery could change what we know about them. The egg is also unique because it has a thin eggshell and no pores, which is totally different from most dinosaur eggs. It actually looks more like the eggs of lizards and snakes, but it came from a giant creature related to these animals. No known dinosaurs or flying reptiles from that time and place were big enough to lay such a huge egg, so it must have been a mosasaur after all. But we can't be 100% sure. Scientists did a lot of work and studied 259 types of living reptiles, like lizards and snakes, and their eggs. From this, they figured out that the mommy who laid the egg was probably at least 23 feet long, not counting her tail. During the late Cretaceous period, this part of Antarctica might have been like a nursery. Paleontologists have found bones of tiny mosasaurs and plesiosaurs in the same area, along with bones from the grown-up ones. Archaeologists in Norway made another cool but literally discovery and found dozens of arrows that had been hidden in ice for 6,000 years. They were melting out of a large ice patch in the high mountains, covering an area of about 45 football fields. In 2014 and 2016, when the summers were extra warm, scientists went to an ice patch called Langfoni to look around. They also found lots of reindeer bones and antlers there. Some of the arrows were whole and some in pieces, along with 5 arrowheads around the melting ice patch. This is more arrows than have been found at any other frozen site in the world. Some of the 68 found arrows date back to the Neolithic period, and the newest ones are from the 14th century of the Common Era. Ice is like the perfect time machine that can preserve whatever ends up there in an almost perfect condition. Langfoni became famous as one of the first ice patch sites after a local hiker found a 3,300-year-old leather shoe right next to its edge. Scientists are studying places like this to understand how people use these sites and how the ice patches from Norway to North America changed over time. Now, once upon a time, around 32,000 years ago, to be exact, a squirrel buried some seeds near a river in Siberia. Am I the only one getting the Ice Age vibes? Anyway, these seeds belong to a plant with cute white flowers. Thousands of years later, a group of scientists found these seeds buried deep in the frozen ground, about as far down as a 12-story building is tall. The seeds were surrounded by ice and bones of animals, like mammoths, bison, and woolly rhinoceroses. The mature seeds had been damaged, maybe by some squirrel, but some of the younger seeds still had good plant parts inside them. The scientists carefully took those out and put them in small containers to help them grow. And here comes the coolest part. They were able to grow the plants. Their flowers were shaped a little differently from the flowers of the same plant that grows today. After a year, the Ice Age plant even made new seeds. Based on this, the scientists suggested that permafrost could be a depository for an ancient gene pool, and we could find extinct species there and bring them back to life. Scientists on an icebreaker in Antarctica were looking for whales, but found something way more unusual. The camera behind the ship, which is as heavy as a car, detected 16 million ice fish nests on the floor of the Weddell Sea. The nests were located about every 10 inches in all directions and covered an area of 93 square miles, which is slightly bigger than the whole of Washington, D.C. The colony even had a distinct border, which was a line in the sand. The scientists were in the area because they were studying a special spot in the ocean where the water was a little warmer than the water around it. In this warmer water, they found tiny animals called zooplankton near the top. When the young ice fish hatch, they swim up to this area to eat the zooplankton before going back down to the seafloor to grow up and have their own offspring. Since there was so much food, it made sense to see ice fish in this warm water. But they didn't expect to find such a huge number of ice fish nests, much more than anyone had ever seen before. New Zealand's Antarctic Heritage Fund found some old photo negatives in a hut in Antarctica. They turned out to be unique images from the Ross Sea Party. It was a famous failed expedition led by Ernest Shackleton. He wanted to become the first person to cross Antarctica by land, from the Weddell Sea to the Ross Sea, passing through the South Pole. But things went wrong when their ship, the Aurora, was blown out to sea. They had to use the hut from another explorer, Captain Robert Falcon Scott. His goal was to be the first person to reach the North Pole, but sadly, he didn't succeed either. The negatives were made of cellulose nitrate and were found stuck together in the small box. The trust took the negatives back to New Zealand, where they carefully separated them and discovered 22 hidden images. Many of the photos were damaged, but the trust could still recognize some familiar places around McMurdo Sound, a well-known area in Antarctica. No one knows for sure who took the pictures. In December 2021, some scientists noticed a strange mark on the Larsen ice shelf, a giant sheet of ice off the eastern coast of Antarctica. They thought it might be a river flowing under the ice, so they drilled down over 1,600 feet to check it out. They expected to find water, but they didn't expect to see that the water was full of fast-moving creatures called amphipods. The scientists also found that the water in the underground river had unusual layers of currents moving in different directions, which they still don't fully understand. Another surprising thing happened during their research. On December 20th of the same year, a volcano erupted far away in Tonga, and the pressure waves from the eruption were detected all the way down in the ice river in Antarctica. It shows how everything on our planet is connected, even in the most distant places. The coldest part of our planet, Antarctica, keeps surprising us. Take a look at this waterfall named Blood Falls. Reddish water falls from the white ice. Scientists concluded that the color is related to iron. The water coming from the glacier oxidizes and rusts when it's exposed to oxygen, and the red color occurs. Step on Mount Gandig. It lays eggs. Well, maybe not real eggs, but the stones certainly look like dinosaur eggs. That's why the mountain got its fame. Let's call them stone eggs, formed in one part of the mountain over 500 million years ago. Interestingly, this phenomenon repeats once every 30 years. Eggs come out in various sizes and shades. The stones appear on the surface of the cliff. A study made in the area has revealed that the composition of the stones of the cliff isn't similar to other parts of the mountain. Here, calcareous rocks rule. They're more prone to erosion. They ripen off day by day. It took 3 decades for the stones to get to the egg shape. Yet, it's still a mystery how these rock formations can be so perfectly spherical and smooth. According to scientists, every stone egg has an organic core. They're made of shells, plant remains, fish teeth, and skeletons. Maybe this has something to do with it. Gulu village is close to the stone eggs. Locals believe that these eggs are sacred. Villagers associate it with good fortune. In fact, nearly every family has one of these eggs in their house. Unfortunately, there are only about 70 eggs left, so if you want to see them, you gotta hurry up. The Richat structure is a circular geological phenomenon in the Sahara Desert near Mauritania. It's made out of rocks in layers, and these layers look very much like rings. No wonder the unique structure even got NASA's attention. Up from the sky, the geological feature seems to be swirling and spinning. Scientists are still not sure how these rings got there. Some say it was an asteroid impact. Many others believe that it was a natural geological process. To them, the Richat structure is an uplifted and eroded dome. Geologists often classify it as a domed anticline. The scientists discovered that the rocks at the center are older than the ring-shaped outer rocks. So it seems like the stones have been eroded to flat rock layers. Anyway, there's no valid explanation for this phenomenon, and the 28-mile-long mystery of the Sahara is still to be solved. Number 4 is Rapa Nui, or Isla de Pascua, but I bet you know it as Easter Island. Yeah, it's got 3 names. It was discovered by Jacob Roggeveen, who actually never intended to look for that island. He just casually landed there one Sunday. That's where the name comes from. Jacob was supposed to find Terra Australis. Disclaimer, it's not Australia. This one never existed and was nothing but a hypothetical continent. Plus, he wanted to peek at Davis Land, which was believed to have once been seen by Edward Davis, the pirate, not Edward Davis, the saxophone player. Jacob failed at that too, though nobody ever saw that island except for the pirate Davis. Jacob may have failed to discover some lands he wanted to, but he discovered Easter Island instead. This is an island and special territory of Chile, located in the southeastern Pacific Ocean. It's on my list because nearly 1,000 stone statues called moai were found there. They were created by the Rapa Nui people. Nearly all statues represent gigantic heads, but there are also a small number of figures kneeling with their hands over their stomachs. Each statue represented chiefs or other important members of Easter Island society. To curve those statues, the locals used volcanic stones that were softened. Our next stop is the gateway to the underworld. Nah, don't worry. This is just how people labeled Darvaza gas crater in Turkmenistan. This giant natural gas crater has been there for 5 decades. This crater is continuously burning gases. The president of the country wants experts to find a way to extinguish this continuous firing pit. This site was created by people accidentally in 1971 while working on a natural gas project. Ever since then, the flames have been on, and it's become a tourist attraction. Mysterious constructions are sometimes built in our era, too. We don't have to go millions of years ago to long-gone civilizations. Edward Leedskalnin single-handedly built a structure called Coral Castle in Homestead, Florida. He didn't use any large machinery. He carved and sculpted more than 1,100 tons of coral rock in 28 years until 1951. It's a mystery how he managed to do it all by himself. Leedskalnin sculpted the sedimentary rock into different objects, such as walls, tables, chairs, a fountain, and a sundial. There's of course a legend behind this mystery too. He was inspired to build the structure after being abandoned by his fiancée on their wedding day. Runaway bride. Well, he wanted to prove his love to her and the world, so he wanted to do something extraordinary. Well, he definitely nailed it. Now let's talk a little bit about the mystery of the Namibian fairy circles. There are millions of circular patches in hundreds of miles ranging from 10 to 65 feet in diameter. They're called fairy circles because they look like a fairy or an otherworldly creature made them. These are essentially oval-shaped soil surrounded by grass. There are a lot of local beliefs surrounding the creator of these marks, yet science says something else. Biologists and mathematicians have been puzzled by the mystery of the Namibian fairy circles for decades. There is more than one theory to explain this phenomenon. Here's one popular theory. The water is limited in the desert, so plants compete to reach the water. Some plants expand and thrive into a patch, but smaller plants nearby cannot get the necessary water to live. In the end, some vegetation disappears, and the remaining ones stay at the patch's edges. That's why they form such regular distant gaps. What if I tell you that there is a hill in Leh City, India, where instead of rolling downwards, things roll uphill? It's an optical illusion. The road looks like it's a sloping hill because of its surrounding landscapes, yet the road actually goes down. These kinds of hills are called magnetic hills or gravity hills. Scientific explanations vary. The most common theory says that the hill has such a strong magnetic force that it can pull cars in the vicinity. Now, how about seeing some flaming rocks? Antarctica spread over an area of over 3 square miles. The place is located on a rocky mountain in southwest Turkey near the town of Çağrıoğlu. Antarctica got its name from its appearance. It literally means flaming stone. The rocks have been flaming for at least 2,500 years, and they'll probably keep burning for the coming decades. The mountain where the rocks are is an inactive volcano, so it's full of tiny fumaroles that release gases such as methane. The gas ignites when it comes into contact with oxygen and creates the flaming effect. And by the way, back in the day, sailors used the flames as a natural lighthouse, as it's really close to the sea. Today, it's more of a tourist attraction, though. Hikers love it too. Now, walk on this frozen Lake Abraham in Canada. In winter, the frozen water gets filled with ice bubbles. It looks magical, but these white orbs aren't that safe. They consist of flammable methane gas. Ew. Beauty can be misleading. The next one is from Racetrack Death Valley, USA. There is a dry lake bed with moving rocks. Now these odd rocks look as if they've been pushed or dragged by someone or something. They leave both a trail and a mystery behind. The force behind all this is now understood. Surprise! It's the wind and some ice. Scientists say the wind pushes the rocks during brief windows when the soil is covered with ice. Now, I can't help but notice that many mysterious things on Earth involve stones or rocks, or methane. Which one of these phenomena is your favorite?
Tiny microbes, basically ancient germs, have been frozen in Arctic ice for tens of thousands of years, just chilling there, since woolly mammoths were still walking around. And now, scientists think these little guys might wake up again if Arctic summers keep getting longer and warmer. Yep, you heard right. Zombie microbes. Great. These microbes have been stuck in permafrost, which is soil and ice that stays frozen solid year-round. The top layer melts a bit in the summer, but the really old stuff, those Ice Age microbes, are buried way deeper. They only thaw if things get really warm for months, not just a hot day or two. To study these microbes, the team went down to the Permafrost Research Tunnel near Fairbanks in Alaska, a long underground hallway 50 feet below the surface, carved right into the ancient frozen ground. The tunnel stretches over 350 feet and lets scientists literally walk through thousands of years of frozen history. By the way, while checking out the walls, the researchers also spotted bones of mammoths and bison sticking out of the ice. One of the reasons why the researchers went to Alaska was to see how fast these ancient microbes could come back to life. Well, they were in for a surprise. These microbes don't need years, centuries, or magic spells to wake up. Just a couple of months of warm weather. Once they're awake, they start doing their microbe stuff, which includes pumping out greenhouse gases like CO2 and methane. And that's bad news, because those gases warm the planet even more. This melts more permafrost, which wakes up more microbes, which releases more gas. You get it. Basically, it's a nasty climate loop. Anyway, when scientists went down into the frozen tunnel to grab chunks of super old permafrost, the first thing they noticed was the awful smell. It wasn't just the stench of an old basement. It was something has been frozen for thousands of years and is finally waking up bad. Weirdly, microbiologists were happy. Such a smell is actually a good sign for them because it usually means tiny creatures, microbes, are still around. Back in the lab, the team soaked the frozen samples in the water that had a special kind of heavy hydrogen inside it. This helped them track what the microbes were doing later. Then they put the samples into fridges at 3 different temperatures: cold, kinda cold, and not too cold, to copy what future Arctic summers might feel like if the warming continues. For the first month, almost nothing happened. Even the warmer samples barely changed. Only a tiny number of microbes started waking up. Basically, a microscopic trickle of activity. But a few months later, things got more exciting. Thanks to the heavy water, scientists could watch how much of it the microbes used to build their cell membranes. It helped them figure out that the old microbes were making special fatty molecules that might help them stay alive in freezing conditions. By the 6-month mark, the samples that were stored at the warmer temperatures had transformed completely. They became more active and started forming little slime layers. The scientists could actually see these layers even without a microscope. The whole community of microbes wasn't super diverse, but those that were active behaved just like modern microbes that live in unfrozen soil today. In short, those ancient microbes were definitely alive and got pretty energetic once the temperatures were warm enough. This matters a lot for the Arctic and for the whole planet because these microbes survive by eating old organic material trapped in the permafrost. When they eat, they release greenhouse gases like carbon dioxide and methane, and the Arctic is warming faster than any other part of Earth. It means that the deep frozen layers might stay warm long enough for huge numbers of ancient microbes to wake up and start pumping out gas. Right now, northern permafrost holds about twice as much carbon as the entire atmosphere. If a lot of that carbon gets released, it could speed up the warming of our planet. It can lead to dramatic consequences, setting off a whole chain of huge changes and affecting basically everything on Earth. Extreme weather will start happening more often. Stronger hurricanes, heavier rainstorms, longer heat waves, bigger wildfires. The oceans will rise too, which can flood coastlines and put towns and cities at risk. Animals, plants, and entire ecosystems can get thrown out of balance, with some species struggling to survive and food chains breaking down. People all over the world will have to deal with crop failures, water shortages, and damaged homes or infrastructure. Let's get back to our zombie microbes. The thing is, the study only looked at them in one place in Alaska, but there's a massive amount of permafrost all over the world, in Alaska, Canada, Siberia, and many other places. And microbes in different regions might behave differently as things warm up. Scientists still have tons of work to do to figure out what's coming next. I bet you're questioning yourself. Could ancient viruses infect us? Well, most of the ancient microbes frozen in permafrost are totally harmless. They're like old bacteria that only care about messing with other tiny organisms in the dirt. But scientists worry that a few of these frozen germs might be the kind that can infect people, animals, or plants. And if that happened, our bodies probably wouldn't recognize them at all, because they've been frozen since mammoths existed. Basically, there's no immune system cheat codes for us. The risks of this happening grow for a number of reasons. For one thing, the Arctic is warming almost 4 times faster than the rest of the planet. Longer summers plus hotter temperatures mean more permafrost melting. So, more ancient stuff is waking up. Plus, people might start digging more around there. Companies will mine more, drill for oil, and ships can travel new routes. All this activity tears open ground that used to stay frozen solid. This increases the chance that someone or something comes across some ancient germ that just woke up. What would actually happen then? We might run into different zoonotic diseases, basically germs that jump from animals to humans. This already happened once. Thawed reindeer carcasses released anthrax, a rare and serious illness which then infected people and animals. Luckily, we do know how to treat anthrax. But what if something even older wakes up? Besides, our immune system might have zero defense. If a virus hasn't been around for tens of thousands of years, humans today would be like, what is that thing? No antibodies, no memories of it, nothing. But the scariest part is that we don't know what's hiding down there. Scientists think permafrost might be storing trillions of frozen microbes, many of which we've never seen before. Some might be boring, and some might be super dangerous. So what if one such virus finally thawed out? The world would be dealing with a disaster no one has ever seen before. This wouldn't look like a normal outbreak. It would feel more like something out of a horror movie. First, the virus would be totally new and our immune systems definitely wouldn't recognize it. That means the virus would spread crazy fast, jumping from person to person. No one would know what to expect. It could cause weird illnesses, sudden fevers, or even something way more dangerous. Stuff as scary as the diseases people faced in old times. Scientists digging in permafrost already look for traces of those ancient diseases, so it's not impossible. Once it escapes, the virus wouldn't stay local for long. With people traveling everywhere and companies rushing into the warming Arctic for mining and shipping, the infection could go from one small Arctic village to major cities all over the world within days. Hospitals would fill up instantly and doctors and nurses would run out of supplies. Businesses would shut down. Food supplies could crash if the virus hit farm animals or crops. Shipping and travel could freeze completely. Fear and panic would spread around the globe almost as fast as the virus itself. There'd be no vaccine and no cure, because no one has ever seen this virus before. Scientists would have to start from zero. In short, a zombie virus outbreak would be totally unpredictable, and the modern world is certainly not ready for it.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data: satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen in sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse.
Some places don't look important until the world realizes they hold the keys to the future. That's the case with Canada's Arctic. For most of history, it was just ice, snow, rocks, caribou, and even more ice. But now, it's about to become one of the most important places on Earth, and maybe make Canada a global superpower. Why? Because it's hiding minerals that power electric vehicles, satellites, and missile systems, while the demand is skyrocketing. However, it's not just mining and having resources, it's also about control. Right now, China has a massive head start because it refines over 90% of the world's rare earths. That means if you want to launch a satellite, manufacture advanced electronics, or even just keep the lights on in your fancy smart home, odds are you're relying on China. And that makes a lot of world powers very nervous. Because when everything's going electric, the last thing you need is being dependent on your geopolitical rival. So now, the global clean tech treasure hunt is officially on. The US, Europe, Japan, Australia, they're all competing. However, the latest technology and untapped potential might give Canada the upper hand. Canada's had these minerals for decades, but with low prices, tough terrain, and no global rush, they mostly stayed untouched. However, Ottawa is finally stepping up its game. Back in 2022, Canada rolled out the Critical Minerals Strategy with billions in funding and tax perks to get companies digging. There's also plans to build the necessary roads, ports, and power lines to tap into those remote deposits up north. Canada already produces more than 60 minerals and metals, but 31 of them are now considered critical. 6 of those are having VIP treatment: lithium, graphite, nickel, cobalt, copper, and rare earth elements. But digging it up is just step 1. The real plan? Keep it local. Melt that frozen treasure into shiny new batteries right at home. That means not just mines, but also refineries, processing centers, and high-tech factories popping up where there used to be nothing but snowdrifts and silence. While others are talking, Canada's busy paving roads and stringing power lines. Slowly but surely, they're turning snowfields into a high-tech playground. Getting to all that buried treasure used to be nearly impossible. After all, we're talking about land so remote that roads literally stop hundreds of miles too early. The ground is frozen solid for most of the year. And even if you found something valuable, just getting out was a logistical nightmare. So what changed? Canada has an ace up its sleeve. Don't know about you, but I use it mainly for making memes and music. But geologists? They're scanning the Arctic like it's Minecraft with X-ray vision. Instead of drilling blind, they're using decades-old core samples, plugging them into AI, and getting shockingly accurate predictions about what's underground. It's like upgrading from a pirate's treasure map to a GPS that actually says, "Dig here." Companies like Geologic AI and Cobalt Metals are already doing this, pouring data into AI and getting X marks the spot hits for nickel, cobalt, and rare earths. In the Northwest Territories, Canada is running a pilot lab that uses AI and digital scanning to reanalyze decades-old rock samples. The goal is to spot hidden mineral deposits that old methods might have missed without digging a single new hole. All that sounds great, but maybe I made it sound simpler than it is. Digging up the Arctic is a logistical nightmare. For starters, this isn't just a remote patch of land. The Canadian Arctic is huge. Almost half the country, stretching over Yukon, the Northwest Territories, and Nunavut. We're talking about a region larger than India, with fewer people than a small city. Most of it is permafrost, wilderness, or ice-covered islands scattered across the Arctic archipelago. Temperatures go from barely 50 degrees Fahrenheit during summer to negative 40 degrees Fahrenheit or colder, with ground that stays frozen for most of the year. Fun fact, did you know that negative 40 degrees happens to be the same as negative 40 degrees Celsius? It's the one temperature where both scales intersect. They climb at different rates, but eventually cross paths when it gets cold enough. Just a small trivia nugget for weather nerds like me. Anyways, you can't just roll in a truck and break ground in the Arctic. Up there, roads just stop. Want to build something? It can take years, and one nasty winter can put everything on ice. And if you want to continue up north, you need more of everything. more food, more fuel, more machines, which means even more money. Speaking of money, another chilling fact is how much this all costs. Mining in the far north is way more expensive than doing it in, say, Australia or Chile. An AI might tell you where the minerals are, but people and big machines still have to dig, and that costs a fortune. But that's not all. Most of the Canadian North is Indigenous land. First Nations, Inuit, and Métis communities have lived there for thousands of years, and mineral hotspots often sit right on their ancestral grounds. So when Canada talks about unlocking the Arctic, it's not just a question of roads and robots. It's a question of partnership and collaboration. And that's not optional. Legally, projects on Indigenous land require consultation and, in many cases, consent. The good news, some communities aren't just involved, they're leading the way. In regions like Nunavut and the Northwest Territories, Indigenous-owned corporations and world powers are already shaping how development happens on their terms. If Canada wants to pull this off, it's going to need more than tech and funding. It's going to need trust. So with all that in mind, can Canada pull this off? Honestly? With technological advancements and partnerships, it doesn't seem impossible. But Canada isn't just doing one thing right. It's doing a bunch of things at the same time. Let's recap. Hidden resources? Checked. New strategy? In place. Big funding? Approved. AI tools? Deployed. Indigenous partnerships? Underway. Infrastructure? Already breaking ground. It's a snowball turning into an avalanche. Exploration boosts investment. Investment speeds up roads. Roads unlock more deposits. More deposits attract more factories. It's a feedback loop, and if they keep feeding it, the whole Arctic operation could go from an idea to empire faster than anyone expects, giving a whole new meaning to the phrase frozen assets. But this doesn't just help Canada. It could save the US a whole lot of trouble. If all goes to plan, the US won't need to ship rare earths halfway across the planet. It can just look north, wave at the caribou, and get what it needs from its closest neighbor. That's why the US has publicly backed the effort, offering support and funding to help build a trusted North American supply chain. For Canada, this could be the moment it stops being just a supplier of raw materials and starts becoming a critical power broker in the clean tech economy. For the US, it's like discovering your neighbor has been secretly building a battery factory in their backyard, while you were building electric vehicles. And globally? Well, the abundance of resources tends to lower the prices, and that's always a good thing for us regular people. Cheaper cobalt, nickel, and lithium mean cheaper batteries, and cheaper batteries mean more affordable electric vehicles, energy storage, phones, laptops, the works. Now, don't get too excited just yet. Like we said, mining in the Arctic isn't cheap, but in theory, once Canada's clean tech engine is fully up and humming, more supply and shorter supply chains should gradually bring costs down. And it's not just about price tags, it's about stability. Right now, if one country cuts exports or gets caught in politics, everything down the line gets shaky. But with Canada stepping in as a reliable supplier, the global system might get a bit more breathing room. Manufacturers can stop sweating over single points of failure and start building with confidence. A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go, But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since Ice Cube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.